Type C is phosphate transport. So that doesn't allow the phosphate to get transported out. Well, guess what? If you have phosphate transported out and you just want to do a simple delta G calculation, it becomes pretty obvious to you pretty quickly that if that phosphate is building up, you're going to change delta G from a negative to a positive, and it's going to be difficult time converting that glucose 6-phosphate to glucose plus inorganic phosphate because the phosphate level is up. Type D is the glucose transport out, and again the same problem. So this is glucose 6-phosphate. I'm sorry, this is glucose 6-phosphate transport in. It's not glucose. So glucose transport in, but as glucose 6-phosphate, and this is glucose transport out. So can't get it out. You're still going to have the same problem. This happens in about one. It's an autosomal recessive trait in general. Happens in about 1 out of 100,000 births. You got to be able to think about what you're going to affect the systems. If you have one of these variants, you're going to have a difficult time maintaining blood glucose. So these people are going to be prone to low blood glucose. And you're probably going to find out about this pretty early on if you're a pediatrician, because you're going to have an infant that tends to be irritable, seems to be hungry all the time, seems fatigued. Don't look at me, I never had an infant to deal with, but that sounds like the general classification for all of them here. Hungry, irritable, what? The reason I didn't have it. I'm sure it would have turned out like me if I'd had it before. If you can't break down your glucose 6-phosphate, one of the things that happens is the glycogen builds up in the liver. So these patients are going to present with they're going to have an enlarged liver because it's going to be difficult for them ultimately to get the glycogen broken down. Diagnosis of this, well, first thing you're going to recognize is you have a parent in there with a infant that isn't doing well. It's more extreme than the average irritable infant. You're going to start looking around, and the problem is that they don't thrive. They can't say what the problem is. They don't thrive. They're unthrifty. But that's going to be symptomology for a whole lot of diseases, including a bulk of the glycogen storage diseases. So you're going to have to take some time to sort out what the real problem is. So diagnosis, well, the best thing you've got going for you is history. What the hell's going on? What happens? Well, it does fine after it gets bad, but it doesn't take too long after that it's not doing well again. So a little bit of history helps. Start looking at blood glucose. It's not going to be maintained. You're not going to maintain blood glucose in that infant when it's shortly after feeding. An hour or two after feeding, that's going to go down. Generally, cholesterol prices and glycerol go up. If you look at blood work, cholesterol prices and glycerol are going up. Even meters are going to go up. And when you deal with fat here in about a week or two, you'll see why. Basically, with that low blood glucose, what the body's trying to do is capture other energy sources, so it's going to start degrading the price of glycerol in the adipose cells, sending those fatty acids off to the liver, so that the liver can use it for energy. So that tends to be up. Lactic acid tends to be up in these individuals as well. Uric acid, so gout can be a problem ultimately. A nice biopsy is a liver biopsy to see if you've got glucose 6-phosphatase and how active it is. Just because it's deficient doesn't mean it's completely absent. There might be a little bit of glucose 6-phosphatase activity. So, what are you going to do for treatment? You've got a patient, can't degrade its glycogen, can't maintain blood glucose. So, what are you going to do? So the test question is going to be just that. Now that we've identified the problem, what do you do? Yes?
Modify the diet.
Okay, how?
So, cut down on carbohydrates and quickly,
Carbohydrates are an issue because they're going to increase glycogen. So that can be an issue.
What you say is low sugar, but then you want to make it.
Basically, yeah, what you want to do though is, in terms of sugars, you'd like to keep sucrose and lactose out of the diet. Sucrose and lactose out of the diet as much as possible. You're going to be better off with a carbohydrate source that's more slowly digested. Now, one of the problems you have with this infant is that you feed it and you put it down at night, and this is when they die. They're going to get very hypoglycemic if you're not paying attention. One of the things they do is they'll feed raw cornstarch to the infant, or if it gets beyond being an infant to whatever age, then they'll feed the raw cornstarch because that's more slowly digested and absorbed. If you're doing that, there's a couple of things you've got to keep in mind. One is you don't want to put whatever it is you're feeding, however you're feeding that cornstarch, you don't want to eat it because that's going to help the cornstarch start to degrade. And then people for a while were putting it in juices, especially fruit juices that had some ascorbic acid in it. And that acid was degraded as well. So you're better off with just a small amount of cornstarch, and that'll help get them through the evening. Small meals, fairly frequently during the day, and again, you want to limit the amount of sucrose and galactose. And basically, that's keeping fructose, glucose, and galactose out of the diet. In a form that's very quickly digested. You're better off with something that's more slowly digested. Some people have talked about using protein, a high protein diet, but that hasn't gone anywhere. Overnight feeding tube in infants, depending on the severity. So use an overnight feeding tube and slowly infuse some cornstarch that's maintained in water. It used to be the outcome for this disease was pretty bad. It's not so bad today. One of the problems you're going to see in people that have this over time, if you're a clinician, is that somewhere around the age of 20 and beyond, you start to see problems with renal disorders. There's renal disease that occurs in these individuals for a variety of reasons, and that'll be an issue with those folks. But it's not as bad as it used to be. The treatment basically is small meals, frequent meals, keep the purified carbohydrates out of it, and look at carbohydrates that take a while to get digested and absorbed, and that's going to maintain your blood glucose overnight. Pretty simple one, ultimately. I told you autosomal recessive, about 1 out of 100,000 people. Type 2. Type 2 is kind of fun as a movie. Type 2 got made into a movie. Type 2 is Poppy's disease. Poppy disease or Poppy's disease is also known as acid maltase deficiency. And this takes us somewhere where we haven't really been. The acid maltase deficiency, basically we're deficient in an enzyme, an alpha-1,4 glucosidase. We're looking at an alpha-1,4 glucosidase. But the alpha-1,4 glucosidase in this case is in the lysosome. And we really haven't talked about the lysosome in terms of glycogen metabolism. We know the process of glycogen metabolism, so we're going to use the phosphorylase to break down the glucose, the glycogen, the glucose 1-phosphate. Some of the glycogen is not going to sit out here in the cytosol. Some of it's going to end up in the lysosome. And the lysosome is kind of it picks up excess. In some classes, they'll tell you what kind of the garbage can garbage disposal does hold. It's going to pick up excess materials in the cell, and it's full of all different kinds of enzymes that are going to break those things down. There's now something like 49 lysosomal diseases that have been reported, and these are deficiencies in various aspects of lysosome function, primarily a deficiency in the specific enzyme that people are concerned with. This is an autosomal recessive disease as well, first described in 1932 by Poppy. There are really three forms. There's an infantile form, so infants, an infantile form, juvenile, and adult. And basically today, they lump juvenile and adult together. I don't see that separated out as much as I used to. The movie about this was called Extraordinary Measures. And it's about a guy by the name of John Crowley, a father, who had two children, two infants, that both have this disease. They both had the right genetic makeup. They were autosomal recessive to the disease. So they both have it. And basically, it's a fatal disease. And John Crowley went to work generating money for research. And that's kind of what the story's about. And several companies were working on enzyme replacement therapy. So the treatment for this is an enzyme replacement therapy. And that is that you give the enzyme that's missing to the infant. The tricky part, of course, is to get that enzyme where you want it. You can fuse the enzyme, but you need the darn thing inside the lysosome. And that's what took the research. How do we get that address? How do we get a label on that enzyme so it goes where we need it? And ultimately, they came up with an enzyme, and two young daughters have managed to live through that. So that's kind of the story. So the lysosome is kind of this garbage collector. It picks up excess, and it's going to be responsible for picking up excess glycogen. And we're going to degrade somewhere in the neighborhood of about 1 to 3 to 4% of the glycogen in the lysosome. If we can't degrade it in the lysosome, we are going to interfere with lysosomal function. So it's not so much the fact that you can't degrade the glycogen. The problem is that the glycogen is now building up in the lysosome, and that's going to impact lysosomal function. So you need to get the glycogen degraded. Infantile. This is going to show up when it's an infant, and usually gets diagnosed around 4, 5, 6 months of age. And generally what you see is an infant that has a considerable amount of weakness, and they have this kind of floppy head syndrome. They can't keep their head up. They've lost muscular tone. They have a real problem with muscular weakness and unable to hold their head up. Breathing is a problem. These patients often, as infants, end up on ventilators, and because they've lost the muscular tone required for breathing. So that's going to be an issue with these patients. There's cardiomyopathy. This is going to have an impact on glycogen that's in the heart muscle, and so the heart starts to enlarge. So we have heart enlargement. So we got breathing problems. We're not a year of age yet. We've got breathing problems. We've got cardiomyopathy. It's not a very good outcome. Usually they die before 12 months. These patients are going to die before 12 months. Late onset, which is really now combined juvenile and adult, there's a late onset variety. And what you see in these people is a decrease in muscle strength. There's especially with legs and trunk. So it's going to be legs and trunk muscle. And again, breathing muscles in the trunk are going to be impacted. Actually, in the late onset, it's going to be breathing difficulties that are often the cause of death with the late onset type. Diagnosis. Well, with most of these now, unlike 10 years ago, I'm going to say that one of the things we're going to consider is genetic testing. It's gotten to the point where we're getting to ask the actually do some genetic testing is still limited, so that's a possibility. The other one is to look at the activity of the alpha-glucosidase that's in the lysosome. There are not a ton of labs around the country that do that, but it's possible to do, and it's getting easier to diagnose this that way. Muscle biopsy, that's always a good one. Do a muscle biopsy, and what you're going to see in that muscle, number one, is there's an increase in glycogen in the muscle. It's normal structured glycogen. So if you see an increase in glycogen in normal structure, as opposed to an increase in glycogen, we're going to look at some people where there's an increase in glycogen in abnormal structure, you can start to narrow down where your enzyme deficiencies are. Abnormal structure, what's it going to be? Well, either it's not going to have as many branches as it should have, or it's going to have too many branches. So now we're looking at branch or a debrancher problem. That's not the case here. You have normal structures that are just a lot of it. So you're unable to use that glycogen effectively. And again, it's really more limited toward the effects on the lysosome. You'll see an increase in glycogen in the lysosome. That's pretty easy to see. You can stain for it. The treatment has come down to enzyme replacement. And the enzyme that they're using now is from Genzyme. Genzyme is called Myozyme. There's a new one out as well. Myozyme is made in a 40-liter bioreactor, and there's a new enzyme that's out that's making in a 60-liter bioreactor. And for reasons that escape me right now, the FDA seems to think it's very different because they're made in different size reactors. Who knows about our federal government? So there's some issues about the other enzyme. So using Myozyme, they are able to get that into the infant, and there's now early infant screening that's available. This country, Taiwan, a couple other countries now do early screening on infants for this disease because it's easy to treat. Treatment is expensive. Myozyme for a year is in the neighborhood of $300,000 a year. Treatment, so there's been issues with a variety of insurance companies declining to pay for it. I think it's a little easier to get paid for in Canada. Insurance companies are a little more liberal about that. Biggest problem, if you have a patient that's deficient, and I don't mean just deficient, I mean actually makes zero of this enzyme, make zero of the acid, they call it acid maltase, the alpha-1,4 glucosidase, lysosomal alpha-1,4 glucosidase. You start putting in that enzyme, and that patient doesn't make any at all, antibody reactions tend to be a real problem. So now you have an antibody reaction because it doesn't recognize, the body doesn't recognize. If you got a little of it, it makes a little bit. It's often the case. Your antibody reactions aren't nearly as bad, but antibody reactions in patients with no acid alpha-glucosidase is really pretty severe. So this is one that's really kind of gotten under control with playing around with bioreactions. Yes, ma'am. I'd like one. That's the problem. You're looking at $300,000 a year for your enzyme, and finding somebody to pay for it, and that's the best we do. In the past, it wasn't much of an issue because there was no real treatment, and these patients tended to die pretty young anyhow. They were usually dead by 12 months of age, so it wasn't that big an issue. Yes. Late onset, it's not clear why they don't show up early, why it shuts down, but some beings do. Evolution. Why it shows up late onset. I mean, we have several diseases that are like that.